Okay, AP Physics B students, this will be a problem that will help you with Chapter 3. We're going to do projectile motion problems. So let's just say that we have, we're going to kick a soccer ball down the football field. And let's say we kick the soccer ball at 20 meters per second. And let's say we kick it at a 30-degree angle. And we want to know how far down the field it goes and how long it's in the air. Let's just ask those simple questions there. Well, to do that, we first of all are going to have to make a triangle out of this, and we're going to have an x. In other words, this velocity is both an x and a y, right? It's two-dimensional. So there's my x and my y, and if we just say 20 times sine of 30, and that gives me 10 meters per second. And if I say 20 times cosine of 30, that's going to give me 17.3 meters per second. All right, and then what I want to do here is I want to make an XY table. I don't know if you guys remember this from last year, but it really helps you stay organized if you have an XY table so you can keep up with all your variables. Where did the variables come from? They come from two equations. They come from delta y equals initial y velocity times t plus 1/2 gt squared. That's my y variables. And then delta x equals initial x velocity times time. And this is supposed to be a subscript made a little bit too. This is initial x velocity times time. That's it. So down here we're going to say delta x equals initial x velocity equals and t equals. And then for our y, we have 4 of them. Delta y equals initial y velocity equals, of course we know already that g equals -10 meters per second squared, and t equals. All right, so when we come fill this in, we're going to kick this ball from the ground. It's going to go, oops, I didn't mean to erase. Anyway, it's going to go up here like this, and it's going to hit the ground again some distance delta y away. All right? And so we start on the ground and end on the ground. So as far as delta y is concerned, that's a change of 0 because we start on the ground and end on the ground. And initial y velocity, we've already done up here. It was the 10. We did 20 times sine of 30. So we're going to write down 10 meters per second. And our initial x velocity was 17.3 meters per second. All right? So we don't know our time, and we don't know our delta x. So we're going to find time first. We're going to use this top equation here. We're going to use this equation right here. All right, we're going to use this equation right here to find our time. So we're going to plug our numbers in. We're going to substitute our numbers in. So 0, that's our delta y, because we start on the ground and end of the ground, equals 10 meters per second times t minus 5, half of 10 meters per second squared is 5 meters per second squared times t squared. We'll put parentheses around this too. So this is a quadratic equation that we could probably figure out without the calculator, but if you get your calculator out and if you still have the quad program that you can just put your numbers in, this is your A for a quadratic equation. This is your B for the quadratic equation, and 0 is your C. If you put those in, you get t equals 0 or 2 meters per second. That tells me that before we began, the time was 0, and after it hit the ground again, the time was 2 seconds. So our time is 2 seconds. All right, that's not too bad. So there's one of our first answers, because we were looking for the time, and now we want to know how far down the field. Well, the time it takes for it to leave the ground and hit the ground is also the time it takes to go the distance delta x down the field, because once it hits the ground, we don't care if it rolls, we just want to know where it hit. And so if we use this second equation, it's v naught xt, in other words, initial x velocity times t. Well, we have those two, so we just use that equation. Delta x equals 17.3 meters per second times 2 seconds. And if you do that in your calculator, you're going to get, let's just see real quick here, yeah, 34.6. So 34.6 meters down the field. A meter's a little bit more than a yard, so it's going to be a little bit further than in 35 yards. So that's how you do that.